The Atlantic Ocean is a graveyard of secrets. For centuries, it has claimed ships, sailors, and explorers, hiding them in the crushing darkness of the abyss. But in the modern age, with our satellites, our radar, and our mastery of the skies, we grew arrogant. We believed we had conquered the void. On June 1st, 2009, that arrogance was shattered. This single image, the tail fin of an Airbus A330 bobbing in the swells, became the defining symbol of the 21st century's most perplexing aviation mystery. Air France Flight 447 was a state-of-the-art machine. It was flown by 3 fully qualified pilots. It was cruising at 35,000 feet. There was no bomb. There was no missile. There was no catastrophic mechanical disintegration. Yet, this 200-ton marvel of engineering fell 38,000 feet out of the sky. It hit the surface of the ocean fully intact, in a flight-stable posture. For 3 minutes and 30 seconds, it fell through the darkness, while the crew fought a battle they did not understand. For 2 years, the world blamed the machine. We blamed ice. We blamed sensors. We blamed a computer revolt. The wreckage lay 4,000 meters down, hidden by the mid-Atlantic ridge. The truth was buried with the black boxes. But in 2011, when those boxes were finally found and the data was downloaded, we realized the truth was far more disturbing than a mechanical failure. The machine didn't fail. The system didn't fail. What happened on board Flight 447 was a terrifying lesson in human psychology, sensory illusion, and the lethal complexity of automation. It is a story of how 3 men, trapped in a dark cockpit, lost their link to reality. This is the definitive story of Air France Flight 447. The night of May 31st, 2009, is warm and humid in Rio de Janeiro. Flight 447 pushes back from the gate with 216 passengers and 12 crew members on board. It is a heavy flight, filled with families returning from holidays, business executives, and tourists. On the flight deck, the hierarchy is established, but it contains a fatal flaw that will only become apparent hours later. In the left seat is the captain, Marc Dubois. He is 58 years old, a veteran with nearly 11,000 flight hours. He has seen it all, but tonight he is tired. He has spent the day in Rio with his fiancée, and reports suggest he slept only 1 hour the previous night. Beside him, initially, is David Robert, 37 years old, a solid by-the-book pilot. He is transitioning to a management role within the airline. He is competent, cautious, and technically minded. And then there is the third pilot, the relief pilot, Pierre-Cedric Bonin, 32 years old. He is enthusiastic, passionate about flying, and his wife is actually in the cabin as a passenger tonight. He has nearly 3,000 hours, but critically, he has limited experience in manual handling at high altitudes and heavy weights. The departure is routine. The Airbus A330-203, registration F, GZCP, is a technological fortress. It operates under a philosophy known as fly-by-wire. In an Airbus, the pilot does not move the control surfaces directly. They move a side stick, which sends a signal to a computer. The computer calculates what the pilot wants to do, checks if it is safe, and then moves the rudder and ailerons. This mode is called normal law. In normal law, the computer provides a hard envelope of protection. You can pull the stick all the way back, and the computer will not allow the plane to stall. It will not allow you to bank too steep. It creates a culture where pilots believe, consciously or subconsciously, that the plane cannot fall out of the sky. 4 hours into the flight, the aircraft is cruising at flight level 350, 35,000 feet. They are approaching the equator. It is time for the captain's scheduled rest. This is standard procedure on long-haul flights. The captain leaves the flight deck to sleep in the crew rest bunk, leaving the 2 co-pilots in charge. Dubois designates Bonin, the most junior pilot, as the pilot flying. Robert moves to the left seat as pilot monitoring. The captain's parting words are routine, but in hindsight chilling. He warns them about the turbulence ahead, not knowing that he is leaving 2 first officers to face the most complex weather system on the planet alone. At 2 o'clock Universal Time Coordinated, the cockpit door clicks shut. The captain is gone. They are entering the Intertropical Convergence Zone, or ITCZ. This is where the trade winds of the northern and southern hemispheres collide. It creates a band of violent thunderstorms that can tower up to 50,000 feet, higher than any airliner can fly. Other flights in the area divert significantly to avoid the worst of the cells. Flight 447 makes only a minor course correction. They are flying into a wall of moisture. At this altitude, the air temperature is minus 40 degrees Celsius. But inside the storm clouds, updrafts carry supercooled water droplets that haven't frozen yet. The aircraft relies on 3 Thales AA pitot tubes to measure airspeed. These are heated to prevent icing. But the density of the ice crystals in this storm is overwhelming. 2:10 and 5 seconds Universal Time Coordinated. The pitot tubes clog with ice. Instantly, the aircraft's brain is lobotomized. The airspeed indicators on the dashboard drop to 0 or become erratic. The flight computers, detecting conflicting data, panic. The autopilot disconnects. The autothrust disconnects. The pilots are suddenly hand-flying a massive jet in turbulence, in pitch darkness, with no reliable speed reading. But the most dangerous change is invisible. The flight control logic degrades from normal law to alternate law. This is the pivotal moment. In alternate law, the protections are gone. The computer will no longer stop the pilot from stalling the plane. If you pull back too hard, the nose will keep coming up until physics takes over. The crew has not been effectively trained for this specific degradation at high altitude. They are startled. Their mental model of the aircraft is shattering. At Air France headquarters in Paris, a maintenance computer begins receiving a burst of automated messages via satellite, ACARS. 2 hours, 10 minutes, and 10 seconds. Autopilot off. 6 seconds later, flight control law degrade. 7 seconds later, rudder travel limiter fault. In just 4 minutes, 24 error messages scream across the data link. It is a digital distress signal, detailing the collapse of the aircraft's systems. Back in the cockpit, pilot Bonin reacts to the turbulence and the autopilot disconnect. He grabs the side stick, and he does something inexplicable. He pulls back. He raises the nose. The plane climbs. It trades speed for altitude. 36,000 feet, 37,000 feet, 38,000 feet. The energy is bleeding away. The heavy A330 is becoming a stone. The stall warning blares. Stall. This alarm is designed to be impossible to ignore. It screams that the wing has lost lift. The solution is basic aviation 101. Push the nose down. Gain speed. But Bonin keeps pulling back. 2:14 and 28 seconds Universal Time Coordinated. The transmission stops. The ACARS messages cease. Flight 447 has impacted the Atlantic. The hull loss is total. 228 lives are extinguished in a fraction of a second. But the world doesn't know it yet. Air traffic control in Senegal waits for Flight 447 to check in. They wait, and they wait. In the middle of the Atlantic, radar coverage is non-existent. Planes report via HF radio. When 447 misses its scheduled check-in, controllers assume it's just static or a radio glitch. It happens. Hours pass. The plane should be entering Moroccan airspace. It should be contacting Europe. Ideally, alarm bells should have rung immediately. But due to a lack of coordination between Atlantico, Brazil, and Dakar, Senegal, the realization of the phantom flight is delayed. It isn't until the flight fails to appear on radar screens in France that the cold reality sets in. By afternoon, the arrivals board lists Flight 447 as delayed. Then, the text disappears. The French government launches an immediate crisis response. The first theories are dark. 2009 is not far removed from 9/11. Was it a bomb? A mid-air collision? The ACARS messages leaked to the press suggest a system failure. But the violence of the disappearance suggests terrorism. On June 6th, 5 days after the crash, the Brazilian Navy spots something. Floating bodies, debris, and the vertical stabilizer. The discovery confirms the worst. The plane hit the water. But the condition of the debris is puzzling. The debris shows compression damage from the bottom up. This rules out a mid-air explosion. The plane was intact when it hit. But where is the rest of it? The vertical stabilizer was found floating, but the heavy fuselage, the engines, and the cockpit, the parts holding the answers, had sunk. They had sunk into the mid-Atlantic ridge, a jagged, volcanic nightmare of underwater canyons and peaks, 4,000 meters deep. Finding a plane here is like finding a shoebox in the Swiss Alps, in the dark, using a flashlight from a helicopter. The search for the black boxes becomes one of the most expensive and technically difficult operations in maritime history. The acoustic pingers on the black boxes only have battery life for 30 days. The French BEA, Bureau of Inquiry and Analysis, races against the clock. They listen. They drag sonar sleds. 30 days pass. The pingers die. Silence returns to the abyss. Phase 1 fails. Phase 2 fails. Phase 3 in 2010 fails. Millions of euros are spent. The pressure to stop is immense. Air France and Airbus are locked in a silent war of liability. Without the black boxes, Air France can blame a defective Airbus system. Airbus can blame pilot error or maintenance. The families are trapped in the middle. By 2011, the investigators are desperate. They turn to a team of American mathematicians, Metron Scientific. They don't use sonar. They use Bayesian statistics. Bayesian search theory is the math of maybe. It takes all the previous search data, even the failed searches, and calculates where the wreckage must be based on where it wasn't. If you search a high probability area and find nothing, the probability of that area drops to 0, but the probability of the surrounding areas goes up. Metron looks at the drift models of the bodies found in 2009. They look at the circle of uncertainty. Their conclusion is embarrassing for the search teams. They predict the wreckage is not miles away, drifting in the current. They calculate it is very close to the last reported GPS position. The early searches had simply missed it, or the terrain had hidden it. They draw a circle. Look here, the math says. April 2011. Phase 4. The final roll of the dice. The team deploys the Remus 6000. It's a yellow submarine that scans the ocean floor with sidescan sonar. For days, it sends back images of nothing but mud and rocks. Then, on April 3rd, the sonar return changes. It shows unnatural geometric shapes. There, in the eternal darkness, lies the landing gear, the engines, and a large section of the fuselage. The debris field is relatively compact. This confirms the vertical trajectory. The plane didn't crash, it pancaked. The robot arm reaches into the silt. It grabs the cockpit voice recorder, CVR. A few days later, the flight data recorder, FDR. They have been under 4,000 meters of water at crushing pressure for 2 years. The memory chips inside are delicate. If corrosion has breached the casing, the data is gone forever. The boxes are flown to Paris. The outer casings are stripped away. The memory units are cleaned and dried. The technicians connect the interface. The room holds its breath. The download bar fills. 100%. The data is intact. The ghost of Flight 447 is ready to speak. This is the moment the narrative shifts. For years, the aviation world expected to see a story of a plane fighting its pilots, a computer gone rogue. What the data revealed was a tragedy of confusion. Step 1. The startle effect. When the autopilot disconnects due to the iced pitot tubes, the pilots are startled. The cavalry charge alarm is loud. The sudden roll from turbulence spikes their adrenaline. Pierre-Cedric Bonin, the pilot flying, makes an immediate, instinctive reaction. He pulls back on the stick. Why? Some theories suggest he was trying to climb above the weather. Others suggest he was reacting to a false sensation of diving caused by the deceleration, the somatographic illusion. Step 2. The fatal input. Bonin pulls the nose up. The plane climbs sharply. The angle of attack, AOA, increases. Because the computer is in alternate law, it does not stop him. The plane zooms up to 38,000 feet. The speed bleeds off. 200 knots, 180 knots, 100 knots. Step 3. The paradox of the alarm. The stall warning sounds for 54 continuous seconds. Bonin and Robert are confused. They are shouting commands. What is happening? We have lost control. Robert, the pilot monitoring, tries to make sense of the screens. He sees the altitude going up, but the speed is crazy. Step 4. The dual input. This is a critical design feature of the Airbus. Unlike a Boeing control column, which is mechanically linked, if I move my yoke, yours moves too. The Airbus side sticks are independent. Robert realizes they need to descend. He tries to push the nose down, but Bonin is still pulling back, perhaps out of sheer panic, holding the stick against the stop. The computer averages the inputs. The plane remains in a stall. Robert does not know Bonin is pulling back. Captain Dubois returns. He stands behind them. He asks, "What are you doing?" But the information on the screens is chaos. The angle of attack is now 40 degrees. The plane is falling at 10,000 feet per minute. The engines are at full power, but they are just pushing the plane forward while it falls flat, like a stone skipping on water, but vertically. And here lies the cruelest twist. At extremely low speeds, below 60 knots, the air flowing over the sensors is so weak that the computer judges the data as invalid. It stops the stall warning. When the pilots push the nose down, the correct action, the speed increases slightly, the data becomes valid again, and the stall warning starts blaring again. Stall. To the confused, terrified mind of the pilot, it seems like pushing the nose down causes the alarm. So Bonin pulls back again to silence it. The logic is inverted. The trap is shut. In the final seconds, the truth comes out. Bonin. But I've had the stick back the whole time. Captain Dubois. No. Don't climb. Robert. Descend then. Give me the controls. Robert takes control and pushes the nose down. But it is too late. The ocean is right there. The ground proximity warning system screams. Pull up. Pull up. At 2 hours, 14 minutes and 28 seconds, the recording ends. The crash of Air France 447 was not a crime. It was a catastrophe of complexity. The pilots were not incompetent. They were qualified, trained professionals who were put in a situation their training had never simulated. They were victims of the startle effect and a CRM breakdown, crew resource management. The legacy of AF 447 is profound. It forced the aviation industry to look in the mirror. It ended the debate on upset recovery training. Today, every airline pilot is trained to manually fly at high altitudes and to recognize a deep stall. They are taught to trust the instruments over their inner ear. It also forced a reevaluation of the Airbus sidestick philosophy and the logic of cockpit alarms. In April 2023, a French court acquitted both Air France and Airbus of involuntary manslaughter, determining that negligence occurred but no direct causal link to the crash could be established under criminal law. However, prosecutors appealed the verdict, and as of late 2025, an appeal trial is ongoing, with no final resolution yet reached. It was a bitter pill for the families of the victims. But the true verdict is written in the manuals of every flight that takes off today. We learned that automation is a tool, not a crutch. We learned that when the computers fail, the human pilot is the last line of defense. Flight 447 is a tragedy of a broken link. The machine didn't fail. The system didn't fail. But on a dark night over the Atlantic, the link between man and machine was broken. And in that disconnect, 228 souls were lost to the deep. Thanks for watching. Stay safe, everyone. See you next time.